This next example, we want to find all of the zeros of f of x equals x cubed plus x squared minus 7x minus 3, but give exact values only, no decimal approximations. It doesn't look like it's factorable even if we use the grouping method. So we can use our rational root theorem, E over Q. Our last constant is a -3. So the factors of -3 are plus or minus 1 and plus or minus 3. The leading coefficient is 1. So luckily that's just plus or minus 1. So any of our rational roots, in other words, our real roots, would either be -1 or +1, -3 or +3. Now, we can look at the function and kind of guess if we plugged in 1 or -1, we're not going to get 0. Remember, we would have to plug it in and get 0 for it to be a root. And with that -7, the ones wouldn't do it. But if we were to plug in one of the 3's, let's try -3. We would get -3 cubed plus -3 squared minus 7 times -3 minus 3, which that does in fact give us 0. So that means x plus 3 is in fact a root. Now let's see what this looks like if we were to graph it. So if we plug this function, let's say, into Desmos.com, we would get this pretty graph here. This is also one way to narrow down all of those rational roots. We can see right here at this 0, this x-intercept, that it lands at exactly -3. But the problem for the other two real zeros, this one is approximated. Notice it's got a decimal, and this one is approximated. So a lot of people think, well, why don't we just graph it and find the zeros? Sometimes you can do that if they're nice. But if you have zeros that involve either ugly fractions or even radicals, you're not going to get an exact answer. So that's where these other methods come in. So we've confirmed we at least have a rational root at -3. If we have x plus 3 as a factor, we can do either long division or synthetic division to reduce our function and find out what that other factor is. So we're going to divide by -3. I'm going to use the synthetic division since it's in that nice format. Using our coefficients from the original function, we have 1, 1, -7, and -3. Bring down the 1, multiply, bring up, -3, -2, multiply, get a 6, bring it up, -1, -3 times -1 is 3, and we get a 0. So yes, we have a remainder of 0. We started with an x cubed, so that means this would be a 1x squared minus 2x minus 1. This is not factorable. So if it's not factorable, remember, if we're trying to solve, we can look at factoring, but we can also do the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then we reduce all the 2's on the outside. We get 1 plus or minus the square root of 2. So all of our zeros would be -3. That's the first one that we found over here. That's the only rational that works. And we took what was left when we divided, set it equal to 0, but it didn't factor, so we used the quadratic formula, and we got 1 minus the square root of 2 and 1 plus the square root of 2 as our zeros.